Welcome back to the Living Soil Garden community. If you're serious about creating a thriving garden that practically grows itself, understanding what's happening beneath the surface is essential. The soil beneath your feet isn't just dirt, it's a living, breathing ecosystem teeming with billions of organisms working in perfect harmony. In this guide, we're going to dive deep into the three primary drivers of soil health: microbes, worms, and fungi. These invisible workers are the reason some gardens explode with vitality, while others struggle despite your best efforts. By the end of this article, you'll understand exactly how to nurture these soil dwellers and why they're more valuable than any synthetic fertilizer you could buy. Understanding the microscopic foundation: bacteria, protozoa, and actinomycetes. Microbes represent the most abundant organisms in soil, with a single gram of healthy soil containing more microorganisms than there are people on Earth. These microscopic workers, primarily bacteria, protozoa, and actinomycetes, operate as the primary decomposers in your garden, breaking down everything from last season's leaf litter to the nutrients locked away in fresh compost. The most fundamental role microbes play is nutrient cycling. When you add organic matter to your garden, bacteria get to work immediately, breaking down complex organic compounds into simpler, plant-available forms. Nitrogen, phosphorus, and potassium move through transformation after transformation, becoming accessible to your plants through this microbial labor. So, this is why a vibrant microbial community often makes the difference between a garden that requires constant feeding and one that, pretty much sustains itself. A particular subset of bacteria really deserves special attention: nitrogen-fixing bacteria like rhizobium. These remarkable organisms, they form relationships with legume plants and actually convert atmospheric nitrogen directly into forms that plants can absorb. This process, which has been documented extensively by agricultural scientists, is the reason why farmers have rotated legume crops for thousands of years. By understanding this relationship, you can honestly harness nitrogen fixation in your own garden without having to rely on purchased nitrogen sources. Beyond nutrient cycling, bacteria act as your soil's immune system. Beneficial microbes outcompete harmful pathogens for space, nutrients, and resources in the rhizosphere, the zone immediately surrounding plant roots. Some bacterial species even produce natural antibiotics that suppress disease-causing organisms. Studies published in the Journal of Applied Microbiology have demonstrated that soils rich in diverse microbial populations show significantly greater suppression of plant diseases than sterilized soils, regardless of other factors. Finally, microbes improve soil structure itself through the production of exudates, sticky compounds released by bacterial cells. These substances act as glue, binding mineral particles into stable aggregates. This aggregation creates the crumbly, pleasant soil texture gardeners love, while improving pore space for air and water movement. The fungal network, nature's internet underground. Fungi represent an entirely different tier of soil organism, and their importance cannot be overstated. While bacteria are individual cells, fungi grow as branching networks of filaments called hyphae, creating vast webs that extend throughout your soil. The most agriculturally significant fungi are mycorrhizal species, which form symbiotic partnerships with plant roots. In return, the plant provides the fungus with carbohydrates produced through photosynthesis. Research from the Mycorrhizal Ecology Laboratory has shown that plants colonized by mycorrhizal fungi often require significantly less irrigation and fertilizer than non-colonized plants in identical conditions. The secondary role fungi play is decomposition of complex, resistant organic materials. While bacteria excel at breaking down simple, readily available organic matter, fungi produce powerful enzymes capable of degrading lignin and cellulose, the tough structural components of wood and woody plant material. As fungi decompose this material, they convert it into stable humus, which improves water retention, nutrient holding capacity, and provides long-term food for other soil organisms. This slow, steady accumulation of humus is how forest soils develop their characteristic dark color and excellent structure over time. A specific fungal contribution warrants mention: the production of glomalin. This compound, produced by arbuscular mycorrhizal fungi, acts as one of the most powerful soil-binding agents available. Research published in the Soil Science Society of America journal has shown that glomalin can account for up to 27% of carbon stored in soils, while at the same time binding soil particles into stable aggregates that resist erosion and compaction. In practical terms, glomalin is why fungal-rich soils have that wonderful crumbly structure that holds together when wet, yet crumbles easily when dry. These macrofauna organisms physically restructure soil through their burrowing activities, creating a landscape that's, well, fundamentally different from compacted worm-free soil. Earthworm burrows create pathways for air and water movement through the soil profile. In compacted soil where earthworms are absent, water either runs off the surface or pools in a layer of clay. In soil rich with earthworm tunnels, water infiltrates deeply, improving drainage while also increasing water availability to plants during dry periods. Studies measuring soil fertility have demonstrated that worm castings alone can improve plant growth in otherwise marginal soils. When worms are abundant, they're essentially distributing this premium amendment throughout your garden continuously. The incorporation function of worms often gets overlooked. As worms consume surface litter and burrow through soil, they're actually dragging organic material from the surface downward, mixing it with mineral soil components. This process is pretty essential for soil health. Creating the conditions for these underground allies to thrive is really important, but understanding these organisms is only half the battle. Research from sustainable agriculture programs consistently identifies 3 primary practices that foster thriving microbial, fungal, and earthworm populations, minimizing soil disturbance, maintaining soil cover, and adding organic matter. These practices, honestly, make a huge difference in soil health. Minimizing soil disturbance means adopting no-till or reduced-till practices. Every time you turn the soil, you're disrupting fungal networks that can take months to rebuild, and exposing organisms to environmental conditions they just can't survive. Soil cover, whether through mulch or living cover crops, protects soil organisms from temperature extremes and, provides a steady input of organic material as the cover breaks down. Finally, adding organic matter, compost, aged manure, leaf mold, or cover crop residue provides food and habitat for all soil organisms. This is honestly the most direct way to support the invisible workers in your soil. Without adequate organic matter, even the best conditions won't support robust populations. Your call to action: join us in building living soil. Now that you understand the incredible work happening in healthy soil, you're ready to build your own thriving underground ecosystem. If this guide has resonated with you, I encourage you to subscribe to the Living Soil Garden channel for more in-depth explorations of soil biology and practical gardening strategies. Share this guide with fellow gardeners in your community. Together, we can shift how we think about soil health. The revolution in gardening happens underground first, and it starts with understanding and supporting the remarkable organisms that make it all possible.